Hi, it's Mrs. Pope, and today we're going to be talking about relations and functions. It may be a good idea to actually pause the video and write this down in your notes, and then start it once you have it all written down, because I'm going to go pretty quickly through the vocab. So our domain, when we talk about domain, we're really just talking about the x values. You'll also hear them as input and independent variable. When we talk about range, we're talking about our y values. We'll also hear those as output and the dependent variable. What does that even mean? Well, the x values, input, that means that's what you're putting into the function. You can put any x in you want, and it's independent. Doesn't matter what you put in. You plug it in the function, you're going to get out a y. Well, that's why the y is the dependent variable. It's what comes out, and we'll look at that. But if you had something like y is equal to 2x, well, y is 2 times whatever number you put in there. That means your domain, you could put any number in there. You could put 100 in there. 2 times 100, 200. But your y is dependent upon what your x is. The function, when we talk about a function, that's a relation where each element of the domain, the x's, is paired with exactly one element in the range, the y. So we'll show this a little bit better in a moment. But just understand that they're paired exactly together. One from the range, or all those from the domain are paired with the range. And a discrete function is here. This is one, you would consider them dots. So they're not connected by a line, they're just dots. They're still a function, but it's discrete. A continuous function is a smooth, I don't think that E should be there, a smooth line or curve. So it could be a curve like this or a straight line that would be continuous, something you wouldn't need to pick your pencil up to draw. All right, these are the types of functions we're going to talk about. So the first one here, we have one-to-one. The domain, 1, 2, 3, and here's the range. So if you have a one-to-one function, each x goes to a unique y. So let's say 1, we would map this. It's called mapping, goes to D, 2 goes to C, and let's just say 3 goes to A. Even though B was left out, it doesn't matter as long as each x goes to a unique y. Okay, so then on to, that's one-to-one. On to, that means each y goes to a unique x. So now we're going backwards. So we're still going to map the same way. Let's say 1 goes to D. Let's say 2 goes to C. Let's say 3 goes to B, and 4 goes to B. That's okay because I still have each y going to a unique x. So my y's are going to a different x. And so it's still a function. Both one-to-one and onto, this is when both the x's and y's are paired with unique values. So here we would just be strictly going straight across, one-to-one. One of these is paired with one of those. They're exactly matched up. The one thing to remember here is that the x's cannot repeat. Here my y is repeated. I basically had 2 y values of b. And when you have 2, you don't write them out. But your x's can't repeat. It can't look like this. You can't have 1, 2, 3, and then the 1 is going to D and C. X's can't repeat or it won't be a function. The reason is when you graph it, it will fail the vertical line test if you have the x values repeating. And we're going to look at that here shortly. So example 1, state the domain and range. Is it a function? If so, which type? So from the types that we just talked about, which type? So here is our relation. We have the ordered pairs. We want to put our domain in. So these would be all of our x values, -6, -5, -3, -1, and 6. There's our x values. Now let's plug in our y values. -1, -9, -7, 7, and -9. But I already have -9, so I don't need to write it again. And then if we want to pair them, let's line them up. -6 goes with -1. This is mapping. -3 goes to -7. -1 goes to 7. And 6 goes to -9 as well. So the question is this a function? Just by looking at this before we graph it, can you tell if it's a function? Well, yes, you can look at it. It is a function. And looking back at your notes, is it one-to-one or is it onto? What do you think? It's definitely going to be onto. If you look back at your notes, you'll see that. So yes, it's a function. and this function is onto. It's not one-to-one, it's onto. All right. Let's talk about that vertical line test I mentioned earlier. So the vertical line test, this is how you can test to see if a graph is a function. This is going to be my vertical line. I'm going to use a ruler. You can use a pencil, you can use your hand. But if you take a vertical line and you run it left to right across the graph, and if this touches the graph in more than one place, it's not a function. Real simple. So here, my parabola, yes, it's a function. It didn't touch in more than one place. Look here, not a function. No, because my vertical line is touching here and here at the same time, so it's not a function. These x's have repeated. Look at this. Can I even tell if it's discrete? Yes, it doesn't touch in more than one place. So yes, it's a function. Absolute value? Absolutely. And what about this here? Oh no, this is touching in like 3 places. Absolutely not. That is not a function. So that's how you can quickly look at a graph and tell if it's a function. Take the vertical line and see if it touches in more than one place. All right, function notation, f of x. When you see f of x, understand that it's just the same as y equals. It's interchangeable. It's not f times some quantity x. It's just function notation. It's read f of x. It's simply the name of the function. You may see g of x, you may see h of x, you may see f of x. Doesn't matter, it's just the name. So just to prove to you that they work exactly the same, if I said evaluate if x is equal to 6, f of x equals 2x squared minus 8. That means f of 6, so I replaced x with 6, is equal to 2 times 6 squared minus 8. Notice I'm not multiplying by f. F isn't a variable. It's just the function, f of x. So this is the function, f of 6. So this function evaluated at 6. So if it's evaluated at 6, we would have f of 6 is equal to 2 times 36 minus 8. F of 6 is equal to 64. So the ordered pair would be 6, 64. If I plug in 6 for x, I get out 64 for y. It's the exact same thing here. So we already know that we would get 64, and the ordered pair would be 6, 64. So they work exactly the same way. Thanks for watching, and remember, you are responsible for your own learning.